Hello, all. Welcome you all back for yet another episode on petroleum refining. In the last episode, we have gone through what is known as primary processing. Primary processing is nothing but distilling of the raw crude into various petroleum fractions in atmospheric distillation unit. The rest of the processes in a refinery, they are known as secondary processing. Today we are going to cover about secondary processing, and in this episode we are going to discuss about the objectives of secondary processing and what for we are doing the various kind of secondary processing unit we are employing in a refinery. When the crude oil is heated and separated into various petroleum fractions, it is known as primary processing. So at the end of primary processing, we get various products like heavy naphtha, kerosene, diesel, and then finally the bottom of the distillation column, which is known as residue oil. The residue oil or reduced crude oil, which has got very less value. It can only be consumed as an internal fuel oil in a refinery. Otherwise, if you are supposed to take it to market, it has got very less value. So, in order to maximize the profitability of the refinery, this residue is taken to the other units where it is cracked and converted into valuable products. And there are some other units where we are trying to modify certain chemical properties of the petroleum streams. So, these are all part of the secondary processing. Let us try to understand the objectives of secondary processing. Number one is to process to meet quality specifications. For example, a naphtha having octane number of 40 to 50 cannot be sold in the market as a automobile fuel. So, it has to be processed in certain plants to enhance the octane number. That is number one objective. Second objective or the most important objective is to convert the residual products. As just now I mentioned, the reduced crude oil is taken to different kind of units like a thermal cracker, fluid catalytic cracker or hydrocracker to convert into valuable products known as LPG, gasoline, diesel, etc. Then the last category of secondary processing is primarily to meet the environmental specifications. For example, reducing or minimizing the sulfur content in products like kerosene, aviation turbine fuel or diesel or lubricants. Let us see each one of them and try to understand each one of the unit objectives and a little more details. The first unit is a catalytic reforming unit. So, as we see the naphtha coming from the stabilizer unit, which will have very less octane number. So, it cannot be taken into the market as an automobile fuel. So, the purpose of a catalytic reforming unit is to convert the low octane naphtha into high octane gasoline. As you see here in the process flow diagram, there are three furnaces, three reformer reactors are there. So, in a stage by stage, the naphtha stream is undergoing lot of chemical reactions. What are the kind of chemical reactions it undergoes? Let us see them. So, in the reforming process, it involves isomerization of paraffins, dehydrogenation of naphthenes like cyclohexane to aromatic hydrocarbon, dehydrocyclization of paraffins. So, all the above reactions finally result in high octane gasoline. So, primarily the aromatic content in the stream is increased and hence the octane number is improved, and in this unit hydrogen is coming out as a byproduct. So, this is the prime purpose of a catalytic reforming unit. Then we move on to the conversion of the residue into valuable products by different kind of cracking process. The first one is known as thermal cracking. When the hydrocarbons are subjected to relatively high temperature over a period of time, the large molecules of heavier oils are broken down into smaller ones such as gasoline and gas oil. So, this is a simple process where the residue is heated in a coil and finally the products are distilled. So, thermal cracking is a process that can be used to get various end products. The nature of the end products depends on the severity of the cracking temperature and the duration. I am not getting into the details of the operating conditions like pressure and temperature, because right now I am giving a overview about the secondary processing techniques. So, you have to remember that the residue is heated over a period of time, and the temperature and the duration of the hydrocarbon inside the furnace, that is going to determine the end products, the number of end products as well as their quality. Then the next process unit is known as whisk breaker, or the process known as whisk breaking. Where it is happening, the unit is known as whisk breaker. Whisk breaking is the mild thermal cracking process. So, as the name suggests, the objective of this unit is to reduce the viscosity on the pour points of the vacuum distillation bottoms to meet furnace oil requirements. Actually, after atmospheric distillation, the atmospheric distillation bottom is taken to the another distillation column known as vacuum distillation unit, because if the residue is distilled at atmospheric pressure, it is going to decompose and finally coking will happen. So, at a reduced pressure at vacuum, then further products are separated out. For example, if the crude has got lube bearing components, the lube oils are taken in the vacuum distillation unit. Otherwise, if it is a crude that does not contain lube bearing components, then we get gas oil. Then the column bottom, the vacuum column bottom, or VC tar, is taken to the whisk breaker, where it is converted into valuable products. In this process, the refinery production of heavy oil can be reduced to 30%. So, we are trying to maximize the valuable products by the whisk breaking process, and it can happen through two different techniques. Then the first technique is known as coil whisk breaker, the second one is known as soaker whisk breaker. Then the most popular cracking mechanism is known as delayed cracking. So, here the principle behind this particular operation is heating is done in a furnace to initiate cracking, and then the reactions are completed in a huge and tall coke drums. So, what does it mean? We have a furnace where the residue is heated, and when the reactions are about to happen, it is taken into a large drum where the reactions happen, and then finally coke is produced. Hence, the unit is named as delayed coking. So, actual coking is not happening in the furnace, it is happening in the coker drum. As a rule, as a series of such coke drums will be put into service in a refinery. While one drum is engaged in getting the feed, the other drum shall be in the process of coking or decoking. But invariably, you will have more than two coker drums will be there in most of the refineries. This way, the orderly rotation of the drums, the process may be contrived to work in a continuous fashion. One drum will be receiving the feed from the furnace, the other drum where the actual coking will be happening, the third drum probably the laborers will be removing the coke from the drum. So, like that each drum will be in different kind of operation. Actually, this is one of the most labor intensive units in a refinery, and but the return on investment is very good, because you are getting a lot of valuable products without a coker unit. Otherwise, this residue would have gone to the fuel oil, which is a very less value added product. And most of the refineries they have, as I said earlier, more than two drums are there, and by the numbers we will call that unit by that name. For example, 6 coker drum plant, 8 coker drum plant, etc. and the coke is solidified in the coker drum, and to remove the coke we have to employ lot of laborers. So the removal of coke is happening through water jets, but of course today lot of automatic activities are being put into use, but still compared to the other units this is a labor intensive unit. Then the next unit is known as fluid catalytic cracking unit, or in short known as FCC or FCCU. So here actually the residue is heated and then finally it is undergoing chemical reactions in the presence of a catalyst. The catalyst are fine solid particles, and the fine solid particles they are in a fluidized state. So it is one of the most important conversion processing used in petroleum refining. It is widely used to convert the highly boiling point, high molecular weight hydrocarbon fractions of petroleum crude oil into more valuable gasoline, olefinic gases and other products. So the FCC unit complex primarily consists of three major sections. One is known as reactor riser, where the actual reactions take place. Then a regenerator or a flue gas separation unit. So the catalyst, as I said, it will be a solid, fine solid particle, and after reaction the coke will deposit on the surface of the catalyst. So the coke has to be removed and the catalyst has to be regenerated. So that is the purpose of the regenerator or the flue gas separator. So both the reactor and regenerator will be positioned adjacent to each one of them, and continuously the spent catalyst will be sent to the regenerator, where it will be burnt, and then the carbon will be burnt into CO, and finally the fresh catalyst will come back to the reactor. So in this process large amount of heat would be generated. That heat will be utilized to produce steam. So of course the reactor temperature will be around 700 degrees centigrade, and that is why lot of safety mechanisms are provided in the plant for any kind of eventuality. The third segment will be the distillation and the recycling plant. So the once the cracking is happening, the heavier molecules are broken into lighter hydrocarbons, and finally all the vapors will go into the distillation column or main column, where the distillation is going to happen, by which we will be able to produce different kind of products like gasoline, diesel, aviation turbine fuel, or the LPG. The catalyst is a solid sand like material that is made fluid by the hot vapor and a liquid fed into the FCC column. Because of the catalyst is fluid, it can circulate around the FCC, moving between reactor and regenerator vessels. So generally to operate an FCC unit, lot of training would be provided. Only a trained manpower will be able to comfortably operate a FCC unit. Then the next cracker unit or the secondary processing unit is known as hydrocracker. Hydrocracker has become a powerful tool to the refiner in the production of quality gasoline, mid barrel products from heavy distillates or fuel oils. So hydrocracking happens in presence of hydrogen, and it happens in a reactor at a pressure more than 100 atmosphere. Most of the hydrocarbon operations are carried out in fixed bed reactors only. So while in the previous case the catalyst is in a fluidized stage, and it is known as a fluidized bed reactor, but whereas a hydrocracker unit, the reactor bed is solid and fixed like a hydrodesulfurizing unit. This process may be conducted in single stage or double stages. The hydrocracker plants operate at more than 100 atmosphere, and a lot of safety considerations are put in place to address any kind of eventuality. So here if we have a once through process, then 100% of conversion of the heavy oil is possible. Of course Since the unit is operated at 100 atmosphere, the metallurgy, the thickness of the reactor and the all other equipments, they have to be appropriately designed. So, of course, this is a cost intensive unit to construct and commission, but once this unit is put in place, most of your residues can be processed and converted into valuable products. So, huge heavy investment, capital investment, but in the long run it is going to give lot of profitability for the refiner. So, primarily the cracking happens using three different techniques. Each one has got a certain value addition in terms of percentage. For example, thermal cracker, it can convert almost 50 to 60% of your residue into valuable products. The next one, fluid catalytic cracking unit, can convert 70 to 80% of your residue into valuable products, whereas hydrocracker unit can convert almost 100% of your residue into valuable products, but of course it is a cost intensive unit. There are certain other units which are part of refinery. So, and all these units need not be present in every refinery. In the previous episode, I have mentioned that depending on the type of crude being processed, depending on the type of products that is desired in the market, depending on the specification of the products, the number of units or the type of units in a refinery will vary from site to site. So, this is known as refinery configuration, and of course, if you want to produce lubricants, then accordingly you have to procure the corresponding crude oil. So many units in a refinery, then the refinery complexity will go up. Apart from the cracking units, then we have some more process units which we are going to cover right now. So, the next one is known as alkylation. Alkylation unit, where the process of producing gasoline range material, light olefins, primarily propylene and butylene, with isobutane in the presence of a highly acid catalyst, either sulfuric acid or hydrofluoric acid. Primarily alkylation units are categorized into two categories, that is, either it can operate with the help of sulfuric acid or hydrofluoric acid. The product, which is known as alkylate, contains a mixture of high octane branch chain paraffinic hydrocarbons which can be blended in the gasoline pool. Here in the alkylation, the process occurs in the presence of an acid such as sulfuric acid or hydrofluoric acid. Depending on the acid, the unit is called either sulfuric acid alkylation unit, that is SAAU, or hydrofluoric acid alkylation unit, HFAU. Here, when you are using in the second category, that is in a HFAU, corrosion is a big problem because hydrofluoric acid is a highly corrosive substance. Corrosion problems that affect the safety and the reliability of the unit. So, all those things need to be taken care. Any section of the unit in contact with the hydrofluoric acid needs to be built with the suitable material in mind. So, it is not like any other unit. The construction, design and operation will be slightly complex than any other unit in a refinery. Then the next unit is known as isomerization unit. In this unit, conversion of a normal paraffins into isoparaffins help in two different ways. Good quality gasoline due to improvement in octane number is the essential result of an isomerization process. Then the next unit is known as air blowing unit for bitumen. So, there are various units which produce highly viscous heavy hydrocarbons which cannot be further cracked or it cannot be further processed based on the refinery configuration. These heavy hydrocarbons known as thermal cracker tar, visbreaker tar, they are all brought to an unit known as air blowing unit. So, the ultimate purpose of this unit is to produce marketable grade of asphalt or bitumen. In layman language, asphalt or bitumen is known as tar. So again, like any other product, tar or bitumen has also got specifications. There are several parameters that determine whether this tar can be taken to market or not. So in order to meet these specifications, the activities happen in air blowing unit. In the air blowing unit, the breaker tar or thermal cracker tar, they are all brought in here, and they are all air blown. So primarily what is happening here, the air blowing unit, the air blowing is done mostly in batch unit, although continuous air blowing units are also prevalent. The asphalt from various sources are mixed and heated to a temperature of 200 to 210 degrees centigrade and sent to the reactor. So in this reactor, you don't have a catalyst bed or you don't have any packing. So it is primarily a vessel where air is bubbled through the different mixture of asphalt. And these reactors are fixed with the air distributors at the bottom and also cooling and heating coils. So normally the reactor will be at elevated temperature, as mentioned, at 200 to 210 degrees centigrade, and air will be blown through the asphaltic mixture. So during this action, the molecular changes are happening, and finally we get heavy tar which can be taken to market. And one important property which is vital for bitumen or asphalt is penetration index. Penetration index, the most important property of bitumen, so it judges the quality of the bitumen. So there are different grades of asphalt produced in a refinery. For example, the penetration, based on penetration index, it can be 30, 40 or 60, 70 or 80, 100. So each kind of asphalt is meant for different usage. For example, for your civic road construction, you require a bitumen of a specific penetration index, while in an airport runway, the penetration index will be totally different. So depending on the market requirements and depending on the planning requirement, the operating conditions would be varied, and accordingly the blending will happen, and finally you produce different grades of bitumen in a refinery. Then we move on to hydro desulfurizing unit. All along what we were discussing was to convert the less valuable product into high valuable product. So now we are coming to a different kind of secondary processing unit which is primarily meant to take care of the environmental needs. So one such unit is hydro desulfurizing unit. It is an important technique in a refinery to minimize the sulfur from various products like kerosene, aviation turbine fuel or diesel, etc. So again, hydro desulfurizer unit is a fixed bed catalytic process. So though the name hydrodesulfurization suggests the removal of sulfur, yet other impurities which can form hydrates are also simultaneously removed from the streams. Hydrogen over a catalyst is capable of reacting with sulfur, nitrogen, halogen and oxygen from the respective compounds available in the fractions. Sulfur, nitrogen and halogen escape as the respective hydrates, while oxygen escape as water vapor. So once the reactions happen in a hydrodesulfurizer catalytic bed, then finally it is taken to different kind of separation process known as high pressure separator or low pressure separator. The gases are taken off, which is known as acid gas, and the acid gas is taken to sulfur recovery unit, while the product which is free of sulfur or with the minimal sulfur is taken as product. The product can be kerosene, ATF, diesel or lubricants. Then yet another set of units in a refinery are the hydro finishing units. These operations are treated as finishing operations for products like naphtha, kerosene, diesel and finished lube products. Not only the removal of sulfur, here in this unit the other parameters like color, stability and odor are selected parameters, and improvements in these make the products more valuable. For example, it is just not enough to reduce the sulfur content in the finished lube oil. We are also supposed to improve its color. Suppose if the lubricant is having a turbid color or brown color, then market acceptance is minimal. So, in order to customers to accept the lubricants need to have bright color, the color improvement, odor improvement, and the stability. All these are addressed in the hydro finishing units. So, hydro finishing unit improve the color and stability of the lubricating oil. It also enables in reduction in impurities and improvement in viscosity index, which are vital properties of lubricants. Okay, in today's episode on secondary processing, what have we learned? Let me summarize. Secondary processing, what is secondary processing and their objectives we have addressed, and what are the three different needs why secondary processing units are essential. Number one, processing to meet quality specifications like octane number improvement, and then conversion of residual products into valuable products, which happen through multiple techniques known as thermal cracking, fluid catalytic cracking, or hydrocracking. Then finally, processing to meet environmental specifications. It can be removal of sulfur compounds or improvement of color or the stability index. So, that is what we have learned. So, let us catch up with another episode soon on petroleum refining. Thank you so much.